Good evening, everyone. Welcome to tonight's Idea Factory. It's my pleasure to introduce Dr. Carrie Diaz Eaton for this evening's Idea Factory. Dr. Diaz Eaton is an associate professor of digital and computational studies at Bates College. She earned her PhD in mathematics from the University of Tennessee with a concentration in mathematical ecology and evolutionary biology. Since then, she has had a vibrant career in applied mathematics and mathematics education. She co-founded and helps lead a number of community building support networks in interdisciplinary and inclusive STEM education, including CUBES, SCORE, and EdSyn. In 2018, Dr. Diaz Eaton was selected as a Leadership Institute Fellow of the Society for Advancement of Chicanos, Hispanics, and Native Americans in Science. And in 2020, she was awarded the Society for Mathematical Biology, the John Young Excellence in Education Prize for her work in interdisciplinary computational math, mathematical biology, and education. She currently serves as the chair for the Committee on Minority Participation in Mathematics for the Mathematical Association of America. And tonight she'll be speaking on models and modeling, a framework for moving towards a more inclusive STEM. Please join me in welcoming Dr. Carrie Diaz Eaton. All right.
Hi all, and it's nice to see folks and see folks wave. Yeah, sometimes on these talks that are in the virtual land, you can't always see folks, so it's nice to be able to do that. And I look forward to spending the next little bit of time with you. So thanks for having me. I'm going to talk a little bit about, as we heard, models and modeling and framework models and modeling. But I want to start with like a very non-STEM way to start, which is to talk a little bit about myself. And this is something that I'm learning to be better at as I work more interdisciplinarily. Is to sort of think of, let you know where I'm coming from as a researcher and educator so that you can better understand how these ideas have formulated and how I and my positionality influences the ideas that I'm talking about today. So I am from New England. I was born outside of Providence, Rhode Island. My father immigrated from Peru in the 60s. We have a lot of family all over the US, but a lot of my father's side of the family is in California. And my mother's side of the family is more New England and East Coast. So we're sort of East Coast, West Coast on both sides of the family. That's sort of, I point that out because it's a little bit of an analogy in the way that these two sides of the family were one way that I grew up in two different worlds. You know, my father being Latino, and my mom being, you know, sort of from more European, you know, fourth or fifth generation immigrant family. My dad being Catholic, my mom being Protestant, my dad's family on the West Coast, my mom's on the East Coast. So a lot of these like different ways in which there were sort of two worlds that I was in and out of over time. Also, just like FYI, two worlds, and Bruce and I were talking earlier, and I was saying something about my kids, and I was like, oh no, not my students that I'm teaching are remote. My own kids, my children are also remote. So another place where I think right now in the contemporary, I'm sort of playing both roles and in two worlds. And then how this manifests in my own disciplinary profession is that I associate with many disciplinary professions, in that I span the worlds of math and biology a lot. I'm a sort of mathematical computational biologist by training. I started in computational neuroscience and eventually moved to theoretical evolutionary ecology, which I really feel like grounds the way that I think about systems. I did a lot of that work as a research assistant in ecology and evolutionary biology department, but I'm a mathematician by PhD. So again, two worlds. And then later, when I moved to teaching in a liberal arts environment, I also started becoming much more active in quantitative education research, thinking about how we help foster the growth of interdisciplinary thinkers among our own students. And so now I've added to already two worlds, maybe a third world of education research on top of that. And then I am rather new to Bates, and this is my third year here after spending 8 years at another environmental school prior. And my move to Bates meant that I moved into an interdisciplinary digital and computational studies department. So it's been really interesting. I'm a mathematician that's never been in a math department in a lot of ways, other than getting my formal degree. And in fact, at my other institution, I was in a biology department before moving to this digital and computational studies department. Because I move in a lot of interdisciplinary spaces, but not only because of that, because of all of the worlds that I grow up in, oftentimes I have been the only one among the folks who are locally there. And so I've noticed that in order to help me feel more belonging, I've naturally gravitated to things like community building and getting folks together to work on common problems, which works really well if you're sort of an interdisciplinary scientist, right? Of course. But then also, I'm very much an activist at heart, especially when it comes to advocating for students, and in particular in these times, thinking about my students of color. And so if I had to, I know that those things sound weird, like why are you putting community builder and activist next to interdisciplinary thinker? And it goes back to my grounding as an evolutionary ecologist, thinking about creating sustainable, diverse ecosystems, and how do they function together, and why do they function together, and how do we maintain this beautiful amount of diversity? And I have a picture of a plant pollinator system because that was my theoretical model system when I was doing my PhD. So I think about these as building resilient networks that are boundary spanning and really build community. So I'm going to talk a little bit about sort of what some of these community conversations, interdisciplinary community conversations, have led to in terms of thinking theoretically about the frameworks in which we talk about our work and ourselves and STEM as a field. And hopefully give you an idea of a framework that you could potentially use, whether you're thinking about your own work or whether you're thinking about teaching or communicating more broadly. Bruce mentioned that I have been involved in co-founding a number of networks. One of them, which some folks may have heard of if you're in biology or math biology, is Cubes. We are a NSF-funded virtual center that helps provide faculty support for teaching at the interface of computing, math, biology. We started in 2013 with an idea, and now we're at the point where we work with over 100 projects, institutions, societies, businesses, et cetera. And a lot of that work was done through an initial sort of boost in funding through an Ideas Lab, an NSF IU's Ideas Lab, to help start this virtual center. And so part of what we do is providing the support, but especially very early in this work, one of the things we were really thinking about was what are the open questions? What are the open challenges? What can we do to move that forward, synthesize research practices across these sectors, and really understand that better? Cubes has been around for a while, and now and has this really strong partnership with BioQuest, and BioQuest is taking on the management of Cubes moving forward as our NSF fund sunsets. But we've taken a very similar approach and philosophy, or I have branching from the Cubes work to think about broadly. Not just helping folks with content and quantitative skills, necessary for computational mathematical biology, but what does it mean to help faculty with inclusive, equity-minded, social justice-oriented thinking for STEM education as a whole? And so I guess you could say a spin-off TV series is Rios, which is coming to a theater near you. We're launching it this summer, and it's based on some early community building work we've done, bringing together networks of STEM education projects that are really interested in social justice and inclusion and open education, and really trying to think about if we're going to invest in new curricula and open curricula and sharing that, making sure that it really is accessible and inclusive of everyone. Okay, so here's, I don't know if you remember when this type of meme was popular. It's probably really old-fashioned now, but I like it so much anyway, I keep it around. So what does it mean when I think about community building and networks? And I already told you about this sort of scientific theoretical grounding of evolutionary ecology that grounds me, but broadly, I think like my friends thought, you know, I just party, I built community. I mean, that's a party, right? I think my mom would just see like all my posts about, oh, I'm traveling to this conference or this conference. I think society hears network. Maybe they actually think about the structure of a network. My boss, what does my dean think I do? He just sees the presentations I give on my CV, so he probably just thinks I'm doing that all the time. What I think I do is like, we're all gonna like work together to achieve common goals. But I think what actually happens is I think a lot about like marketing and communication and strategic development and growth and all of those kinds of things, you know, project management oriented also things with social engineering that you have to do. But I think it's sort of interesting to bring that up because there are so many aspects, and you know, if you're going to community build in STEM, you not just have to know the STEM, you have to know all of the other things about community building and community transformation and growth that I think actually systems people like ecologists, like modelers think about. And so I had mentioned that with cubes, we were thinking very much about like, as we're doing these like community transformation practices, as we're trying to help the community, what are the practices that exist? How can we do this the best way possible? And we were recognizing that there was a lot of knowledge in a lot of different spaces. So it wasn't just held within mathematics as a discipline or biology as a discipline, it was in all of these places across. And we were able to propose and were accepted to run a working group at NIMBIOS. This is the National Institute for Mathematical Biology and Synthesis that was at the University of Tennessee, to bring together folks in all these disparate disciplinary-based spaces and really come together to think about how best to unpack what it means to teach models and modeling for biology students and teachers. So like, what are the best practices that are held in so many different places? Could we move that forward? Could we figure out what those best practices are? And then through cubes, could we implement those best practices across our system? And so we brought this wonderful, great group of people together, most of which are pictured here, but not all. And you can see in Knoxville, Tennessee. You can also see I'm very short and John Junk is very tall. I don't know for those who know who John Junk is. Yes, he really is like twice my size in height. But I think what's great here is like we've got some folks that come from the math side, we got folks that come from the biology side, we got folks that come also from, I don't know which side I come from, both, you know, discipline-based education research, also, you know, computational biology, professional development, biology education and quantitative biology education, STEM education research, or I should say science education research, like K-12 math, K-12 education research, computational biology. So you can just sort of see there are folks from a lot of different places coming around, some of which really hold like these biology identities, some of which hold math identities, some which hold education research identities, and then folks all in between, right? And we had a lot of really great discussions. We talked about what are the big challenges facing quantitative biology education. I mean, this was not that far after the Vision and Change report. So like 2013 feels like just yesterday, but really it was like, almost a decade ago now. And we were thinking about like, what are some of these grand challenges? What kind of quantitative skills are needed? What works in quantitative biology? So there were a good number of case studies of new programs being developed, but not a lot of information about what was actually working. So like, what do we know about what works? There was a lot of concern, especially among some of the biology community, about math anxiety, and not even so much, not limited to student anxiety, but also instructor anxiety, folks that didn't feel as prepared with the newly emerging technologies and computational skills that were then being asked to teach these. And then we also happen to talk about some cultural issues as well. For example, how is it that we use language differently in disciplines and so forth. And we continued researching as a working group through NIMBIOS. They have a particular structure where you can come together 3 times over the span of 2 years. And then in between this time, we met together as smaller working groups and would do journal clubs and so forth to keep that conversation going and moving. So we had a lot of really great generative ideas, and it was really interesting because, as we came down to our second meeting, it was like we all had all the stuff, we all had all the ideas, but it felt like we were just talking past each other. Like, we know we're all here working on the same problem, but something's not clicking, and it took us a little bit to figure out what was going on. So let me just pause for a second. This is my slide. Pause, Carrie, slide. So I'm going to pause, and Bruce is going to put up a poll, I think. I just really quick, go ahead and launch that.
So I think it's actually, well, let's see. You might see 2 questions that are the same. I don't know why it's doing this again. It shouldn't, but you can just answer one of the polls.
We'll ignore the second one.
Yeah. Okay.
Looks like you have to answer both before they'll allow you to submit. So I guess people will have to answer both questions.
Oh, okay.
Oh, that's a good piece of information. Thanks.
Yeah, thanks, Paul. Okay.
And thanks for humoring us on this. I don't know if you have the ability to share results when everything comes in.
Yeah. So
divide the results by 2.
right. So let's see. Looks like there's one person who hasn't answered. I'm guessing that person is me. I don't think I have the option to actually, so I'm just going to end the poll. And I'm going to share the results.
Okay. So it's about half of you. And some of you aren't quite sure, and some of you are no. But I think it's sort of interesting. We'll try to remember and come back to these figures later. I just wanted to kind of do this as a quick activity to see who was in the room today, who we're working with. Okay. So I'm going to have you do a quick activity. So if you could look around you and pick up some sort of pencil and pen and notepad or whatever. I would like everyone to grab that blank piece of paper and just write down the first thing that comes to mind when you hear model. Go ahead and describe it or write it down or draw a picture or whatever it is you want to do. And I'll give you a couple minutes to do that. Okay, reading some of the body language, I think folks at least have something down. And what I'm going to have Bruce do is open up some breakout rooms, maybe about 3 people per room, Bruce, if that sounds about right. And what I'm going to have y'all do is go ahead and share what you wrote down on this piece of paper with the other folks in your room. And if you can, just also appoint someone to be your reporter outer when we come back. So you should see the invite link. I think we got almost everyone.
Yep. Let's see. Oh, and I guess I don't get to get sent into one.
Well, you can, why don't you make me host?
Oh, right.
And then I'll make you co-host, and then we should be able to get you into one. Or no, you should just, you can just.
Oh, I can just
join.
jump in. Yeah. Yep.
Yeah, but you might have to assign, or actually I think I can maybe assign people. Oh no, I don't have co-host status.
So I'll give you, sorry, yeah, I'll give you the host. So you are now the host, Carrie.
Oh, okay.
There you
Look
go.
at that. I'm gonna assign you to actually I'll just yeah, I'll assign you to a room. And Patrick, I'll assign you to a room. We're just sharing.
And then I wrote ideal example. Like I was thinking like a model car, like when you go into the showroom, there's like a model, or like even a fashion model, which I don't know if that's, you know what I mean, but like this idea of like something exemplifies a certain like practice or production. Those are my 3.
Okay. For mine, I wrote down computer-aided design, because the company I work for, whenever I hear the word model, I just think of CAD and how they design the part and produce the part for a model.
And I said something similar to your last one, Paul. I thought about something that is a simplified, it's like a schematics of a more complex process, or and then you simplify it to the fundamentals, sort of.
Nice.
So, oh.
Go ahead, Valentina.
No, I'm done.
Oh,
Bruce.
Yeah, so I kind of did something similar. I drew a model airplane. That was my first instinct. I think it's because I grew up with model airplanes in my life, that kind of thing. But then I also sketched 2 stick figures talking with like a chalkboard in the background, and they were like discussing some type of phenomenon or something. Yeah. Mm-hmm.
Colin, will you report out for us?
Oh, me?
No, Colin.
I'm Colin.
Yeah, you share out what we discussed?
Yeah, I can do that.
Perfect.
Excellent.
I want to hear from the scientists what's the difference between a model and a theory, but maybe in the Q&A we can talk about that. I'm just interested.
Ooh, that's a really good one. Yeah.
Oh, looks like we're supposed to.
Oh, alrighty.
Thanks, Colin. Nice meeting you, by the way.
Yeah, thanks. Nice meeting you too.
Yep.
Thanks, Colin.
Okay, so I think most folks are back. And Bruce, I gave you host status back, so you might have to tell me when most folks are back. Okay, so so let's do a quick report out of rooms, but I'm gonna sort of structure the conversation in a particular way. I'm just curious here. in your rooms that you went to, and I know y'all shared, oh, I did this, I did this, I did this. Did any room have everyone that wrote down the exact same thing? Buja, do you have your hand raised?
Hi, so Bujo here. Yeah, so it's a good point. So everybody in my room had the same sort of idea, but there was one person who said that they had a slightly different idea.
So there are a few things that people are on board with, some different. And then I saw a lot of head shaking, like, no way, like, we didn't. So, so your room was pretty close, but I saw some head shakes that went, no way, Jose, kind of thing. So does somebody from one of those rooms want to say, like, how different were people's ideas, generally speaking?
I'll say something about breakout room too, because I know I wrote down a flow chart for epidemiology, but one, Sharon Carter had a very, very good verbal discussion sentence of what mathematical modeling is. She should really say that. And Lena was similar, and Andrea was well, there's modeling fashion and modeling building things. And I thought of that too, but I said, well, we're here for mathematical modeling. So.
Okay, Ruth, I'll come out of my shell.
Yes.
I just said that it's a collection of mathematical equations and constraints that can represent and predict real life.
Yeah, it's the most kind of definitional approach. And I love the variety here, because even within your group, I heard pictures and then verbal explanations. And so so it looks like a lot of variety and diversity even there, and modeling in a magazine and so forth and so on. So great example. So were folks surprised about the other things that people were coming to the table with? Or maybe in some cases, if you heard magazine model, and they're, oh, but we're here for mathematical modeling. But like, broadly speaking, there was quite a lot of diversity, even when, we think we're all coming to the same room for the same purpose. So this relates, and the reason why I had you all do this exercise is because it relates very much to what we ended up coming to also as a team. We very much realized that we actually didn't have the same thing in mind when we were talking about models and modeling, and that's where we were talking past each other. So the mathematicians were thinking about constructing an equation from some kind of theoretical concept. The biologists were thinking about fitting an equation to data. Data had to absolutely be there, had to be central. You couldn't do modeling without data, which is not necessarily the way that mathematicians think about models. And this isn't new. To struggle with this kind of, with language development as we're doing interdisciplinary work, is especially in combination with quantitative work in biology. I mean, this is a topic really well explored by Joe Reddish, who works in physics education research, in particular for links between physics and biology. What I think is more interesting, and what I want to sort of also get us to think about a little bit more today, is that this really brought up some really interesting stories from team members about feeling marginalized because of their definitions for models or modeling, or digging up feelings of not belonging, or maybe what we would call disciplinary microaggression. So for example, we had somebody who was a bioinformaticist, and back then, in the early 2000s, working in our department at what arguably now are praised as data science type approaches, taking data and then investigating it in an exploratory way. But her biology department said that's not real science because you're not coming up with a hypothesis first. Oh. And that's very interesting, because wait, you're working with data, right? Like you're somehow coming up with how these theoretical constructs are related to your data, but you're not doing real science. And so it gets us to think about how this language has become a place of marginalization for people. The language of science, the language of models, the modeling. From my own experience, one of the things that I had brought up was that coming from the math side, that I had research students that were working with me on theoretical epidemiological models, trying to see if we could get particular behavior to produce. And my research student who was working with me at the time was ineligible for the biology department research award because they didn't collect their own data. And so again, you could see that one's definition then became a leverage point for not feeling like you're belonging, or this kind of disciplinary microaggression. And so what I want to point out by having that really explicit conversation is that all of a sudden now our scientific constructs are not independent of our social constructs. When we are, defining a field by language, but then that's leading to marginalization of individuals, those two things, science and humanity, become inextricably linked. And so creating frameworks for inclusive language really can help bring some healing and some validation to folks that come to these spaces that we're all working with that same common goal, but sort of helps us understand where we're coming from. And so my answer here is they're all models. And I hope the rest of this talk sort of shows you why that might be the case. But I would say that even if you wrote down a data set, even if you were thinking about a magazine model, even if you were thinking about a mouse model, and a weather model, all of these are models. And the question is, how can we validate them as such so that we can work together better, especially in interdisciplinary teams? So we, through this workshop, came out with our own definition that's not only our own, it's really a synthesized definition that comes from multiple places and put together. All of our areas, from science, from education research, from mathematics, et cetera. And that is that a model is a simplified abstract representation of reality for some purpose. And it can have many forms. For example, verbal. So that's a great example that was shared from one of the rooms. The rate of population growth is proportional to its size, for example. It could be visual. If it's represented visually, that same rate of population growth is proportional to its size is an exponential curve, right? And so you might represent that visually when you're talking to somebody about the type of growth you might see. Oh, this one symbolically too, covering symbolically there, but yes, symbolically it would be another representation. Again, the rate of population growth is proportional to the current size, but that's how to write it with math notation. And then you might even think about numerical representations. So those might actually be the data that if you were to go out into the field and measure, or a lab and measure, then you might actually have that, or perhaps they're in silico generated data. And this representational perspective of a model is not necessarily new. Representations are a theme that come up in a lot of places in math education, but also in calculus reform. So this was a pretty common approach. It was originally the rule of 3 in calculus reform, and was augmented to later to become the rule of 4, which is sort of the verbal, visual, symbolic, and numerical that you see here. So there are pieces of this that already embedded in the way we think about mathematical representations. I'd like to add a fifth to this, and that is experiential. So rule of three, rule of four, again, that has a lot of history in the math community, but the math community might not, in those calculus classes, be thinking about the role of experiential, of actually the act of going out into the field, or the act of observing actual bacteria culture on a plate, wherever you might get a sense of the rate being proportional to the current size. And this is something that is drawn really from collaborating with biologists who, for them, for their disciplinary culture, the experiential is the way into their discipline. Oftentimes, labs are such an important keystone piece of introductory science in many places. And so, taking what we have also as a core in mathematics and adding to it through what's core in biology. And I'll say this rule of five, there are pieces of that in experiential or manipulative is even included in this in just K-12 math reform. These just haven't been put together in this particular way to include all five at the same place, nor applied to modeling. And so if we sort of think about, okay, you've got this like reality, and then you're doing this abstract representation, and then you can have all of these different types of model representations available to you when trying to think about how reality is playing out in your model. And what's beautiful about this is instead of being limited to one framework, if you can bring folks together who engage in all of these different types of models, you have a better understanding of the full picture. And at one point, our team was thinking about conceptualizing this, and they said, well, it's like the blind man and the elephant parable. So you have this elephant, and this, for those who don't know, I'll try to re-narrate this parable. You have an elephant, and then the idea is that there are blind men around the elephant, each touching a different part of the elephant. And if he's touching the trunk, he might think that he's next to a snake. If there's somebody touching the leg, they might think it's a tree. If there's somebody touching the tail, they might think it's a rope. And so if you're only looking at part of it, you might have some information that you can make an educated guess, but you might not have all of the information you need to see the whole picture in front of you. And so that's what was happening to us as a research group. We were talking past each other instead of being able to understand how each of our definitions of model were actually part of a broader same framework. On top of these model representations, we then asked, well, what is modeling? And so we first started by defining modeling activities, which are these smaller steps. They're the acts of moving between representations, for example. So moving from thinking about some kind of hypothesis to setting up a lab experiment to do that. That would be this sort of arrow number 2, right? And that would be a modeling activity. You have to really think about, what am I saying? How do I enact it in an experiential form? For mathematicians, we might actually go right from verbal oftentimes to symbolic. We would say like, oh, the rate of change is proportional to the current size. Let me write you an equation for that. Folks who are doing other kinds of data science type activities might actually just start at numerical. They might not have a hypothesis beforehand, but then might engage in some kind of maybe visualization to understand it better. So the way that we come at some of these questions may really depend on our discipline or even sub-discipline. We all have these sort of cultural traditions within our discipline, so to say, that affect the way that we typically approach problems. And so that may affect our box and arrow use, which arrows we use the most or which boxes we use the most. If you're a mathematical modeler, maybe you're using the symbolic box a lot, but it doesn't affect the framework. It doesn't affect that broader framework, just sort of where you're traversing. Modeling activities are also the act of not just moving between representations, but the act of abstracting from reality to the model representation itself, and then also taking your model and then validating it with back to reality or revising to a new model if necessary. So that's also an important modeling activity. It's not just moving between, but equally important. I also think there's something really nice about pointing out the transition between representations as its own separate activity that's quite difficult for oftentimes in teaching or learning. Staying within a box, learning how to manipulate an equation is one kind of difficult, but then to recognize that it's the same equation as a graph that you might be looking at, I think is a little bit harder in some ways, and recognizing that. And so again, what I like sometimes when I'm teaching and I think about this in terms of my teaching, I might say, well, you know, if I'm teaching calculus, let's just say, maybe I am, you know, this course is going to primarily focus on the symbolic, as, you know, we're going to set up a lot of new notation. We might generate some numerical data. We might explore what some verbal conceptions that we try to then do symbolically. We will also make graphs or analyze, make graphs from our equations and go into the visual. But we might not do a lot of data fitting, which would be starting at numerical and fitting a symbolic equation. You would see that in a statistics course. And I think that helps students understand a little bit like how our disciplines are slightly different. What's the difference between, you know, a calculus course and a statistics course, even though that might seem obvious for us, might not be obvious, broadly speaking. So again, abstraction, moving between representations, and model validation. And if we take all of those three pieces and construct them in various ways, then you can create an entire process of modeling. So if you think now about the process that one engages with on a scientific level, when you go from big idea, big problem in reality, to the way you approach it from either a biology or a physics or a math or a computational side, that whole thing would be the process of modeling. And it's a pathway through the framework, and is probably, as I said, discipline or subdiscipline dependent. For example, mathematical modeling probably includes that symbolic box. In fact, I heard very explicit verbal discussions that, you know, it involves equations. Mathematical modeling involves equations. So you're probably likely to go through that symbolic box. If you're doing something that's more computational, you're probably doing something that involves moving from numerical box to visual, or using some kind of equations to set up some kind of numerical simulation. And so you're probably over a little bit more in this numerical area here. And so you might think about, what is your own process in this box? I'm going to share a few of my own processes just to give you some examples. So this is a research project that I've done with students in the context of classes and elsewhere, but we've modeled zombie data that they do a humans versus zombies game on campus, and we modeled the data as an epidemiological problem. And so we would start with that, like, reality, which is the game that they're playing on campus, and which is very much like, not quite reality, it's itself almost a model, right, of reality. I mean, zombies aren't exactly reality, so, you know, there's that. But then we think about, okay, well, what kind of, we collect the data, so we have the data, we think about why we might be seeing the patterns we see. we create some kind of hypothesis, then we set up some symbolic equations for that, then we simulate that, right, fit it to data, et cetera. And so you can see how I'm traversing a bunch of these eras. Once you see, does it fit? If not, we revise the way that we're thinking about our model and start again. And what I love about this sort of framework, even though it looks a little bit messier than some of the models and modeling frameworks we see in the past, is that I think the joy of it is that it's not nonlinear. And I mean, it's not linear. It's very nonlinear. It allows you to move between boxes, maybe even revisit things a few times, explore, go back in ways that some of our traditional conventions about what models is or how you approach it might be different. And I'll give you yet another example so you can have some other sort of traversing of this. For example, I mentioned I did like some plant pollinator modeling. And so very much I had some sort of conjecture in my head about why we get very diverse ecosystems. I set up some equations to try to characterize that. I ran on 81,000 simulations that are run here to see which of my community ecosystems died or not. I mined those in silico systems to find really interesting statistical information about my community structure and so forth and so on. And so we go back, oh, that wasn't the community structure I wanted. I go back to my model, I revise and so forth, et cetera. And so again, different kind of perspective or way of entering the equation, but can use the modeling framework again. I've also used this not just in computational biology. I just want to show that this is like broader than that. So I did some statistics work related to math for social justice. This was a particular case where there was a controversy in the mathematics community where there were some letters that were written to disparage the use of diversity statements in hiring. And then there were a number of responses from various individuals in the mathematics community, a few letters that were broadly signed by hundreds of individuals in the mathematics community. And some of which were very, I think one of which was like, no, we need to use diversity statements. One of which was like, don't attack the editor for saying that we shouldn't have diversity statements. That was one of the responses. And then another one of which was, nobody needs diversity in mathematics, right? So there were like 3 letters and did a very, statistical analysis of the signatories of that letters to find out like who was saying what and how does their positionality, what does this say about who's in favor of keeping the status quo and so forth. And again, it's still a form of modeling. We're looking at statistical modeling here. So, you have some kind of experiential problem, which is racism in mathematics. And then you have, a model version of that you're using to mine, which are these signatories of letters, which represent some model of how racism operates in mathematics. You think about, exploring that data, maybe running some statistical tests on it, et cetera, going back to your hypothesis. Why are you seeing what you're seeing? Well, no surprise that vast majority of underrepresented people were signing the letter that was in support of diversity statements, and also the vast majority of women as well. And so really thinking about who's interested in upholding the status quo. It's very much not those groups. Last but not least, I'll bring up something in that's less explicitly modeling, which is even my own work, community building and thinking about social media networks and community building. And, I can think about the same thing, we're in this like social media connected world, what is the particular problem that I'm working on? I'm thinking about like, what kinds of things does our community want to learn about on our Facebook page? I look at analytics and I don't even have to do a sophisticated analysis, but I can look at some of the data and see, what are top posts? And that tells me something about what people want to see. People want to see highlights from Mathematically Gifted and Black. And that's like really, really popular this week. this month when I was doing data analytics. And then so we changed our content accordingly. And so again, even things that people might say, oh, you run social media, that's not modeling. All of a sudden you start to see all of these connections and ways that we use things that we might not even realize that we're doing, but now have a place to hang it on, a framework to hang it on. And so the process of modeling broadly is just different ways of moving through this framework broadly, that there are many, many valid paths to get the best picture of reality. And in fact, when we all are looking at it from all these different ways, of course, we're going to have a better understanding of the elephant that's there, and to really help each other figure out what's there. So I think I'm going to like pause to see like where people lie on their own journey. If you do any, or think of yourself as doing any models or modeling, even if you don't think of yourself as a modeler, could you find your approach on here? Like maybe the first 3 arrows even. And if you want to, you can even share in the chat window. And I don't know if everyone's getting through it all, but I can certainly give you the link to this paper so that at any time you can go back and look at it and find your path and chart your path through this framework. But hopefully it gets you to think about things. When I have, sometimes I do workshops on this for teachers, and it's really interesting to see the diversity of paths that come up that get written on the chalkboard. Because everybody does approach things and think about things differently, and it's really nice to see. So I guess I just want to leave us with this thought, that we are all modelers. We might do it very differently. We might have some abstract idea, and our experiential representation is very physical and considered art. But it might also be that we're doing things that are more in silico, or thinking about, oh, is that play or is that modeling? I think there's a lot of other things going on here that we might not even appreciate in all of the activities we engage in every day. And so I think we're all, maybe I would like to think that we are all a little bit modelers inside of us. Even if we don't all identify with a specific mathematical modeling framework or definition specifically. So I'll ask Bruce if you'd like to send out that poll again. And now we know we need to answer it twice to be able to push submit.
Right.
And Bruce, you can share the result. I'm curious to know what the results are. I said, this is not nobody, there's no like education research formally going on here, but I was just curious to see. Oh my gosh, look at that. Like maybe one of you is left unconvinced, but I call this a total win. So I'm glad that I can make you all feel like you belong in this world of models and modeling a little bit more. So thank you all. I hope I've also, in the meantime of talking about this framework, made the case that it should be used in teaching. I think also I talked a little bit about how I think it helps scaffold knowledge and expectations for my students. I also kind of think it's a great tool for thinking about claim and evidence language. So like that evidence can be in a multiple of representations and forms, and how can we recognize that and leverage it? I think also thinking about things in terms of multiple representations is just really good practice for universal design for learning. And so that's also great. And I think it's great where like the processes are actually receiving like their own attention here. It's not just about the graph, it's about like what you need to do to get to the graph, yeah, or things like that. So I just kind of want to point that out too as well. I also think in terms of communication, this is really, really helpful because if we're really intentional with our language, we're going to just be better communicators. And so we want you, we talking about like all of the authors that did this paper with me, want to help you to have more inclusive and productive conversations. I remember that when I was really early on the job market, and I was going around looking for job, I was doing these job interviews. And I remember, it was at a time where I wasn't working with as much data explicitly within the context of mathematical biology. I was doing more like generating data through in silico experiments. And I remember talking to some biology folks and they were like, oh, I'm so excited that, I get to talk to a math person. I have this data and I'd love to show you my data. And I was like, I'm not a statistician. Like I just kept like saying that, like, and I look back on that and I want to like, Carrie, why did you do that? Because what they were actually saying to me was, I want to work with you. I want to collaborate with you. And so by showing me they had data with like an olive branch, and I was saying, I don't want your olive branch. And I didn't understand what I was doing in that moment. And so don't be me, but understand that like, that they're just working on a different part of the problem that you are. I also want to sort of explicitly say that it's not just about making, folks belong on disciplinary axes, but some of the best interdisciplinarians I know are boundary spanners that come from marginalized backgrounds, like myself. When I talk about sort of being in two worlds, I think about that as important to my shaping because I have spent a lot of time, not just code switching between two worlds, but also like helping those worlds understand each other, right? And so I think this is what I do professionally as an interdisciplinarian is like help worlds understand each other through language and common practice of finding where we have things having in common. And so I guess I find that unfortunately, the language that we use that tends to be exclusionary tends to be, it's not just being enacted because of different disciplines, it's also being enacted whether we see it or not, often even particularly on women, on people of color who tend to do this boundary spanning work, for example. And so how do our perceptions of science or what is or what isn't science doing more than just disciplinary microaggression, but actual, social identity oppression. And it reminds me of this really powerful blog that Piper H wrote a few years ago should I stay or should I go? She's a wonderful, wonderful, real deep thinker about mathematics and humanity. And she's there saying, oh, am I mathy enough to stay? She has like a PhD from Princeton. I mean, in math, and she thinks like she's feeling marginalized because she doesn't feel mathy enough or computational enough. And I think like we need to be sending a message that you are enough. What you bring to the table is valuable and brings its own cultural wealth. And we need to get better at recognizing what that is. I think broadly speaking, to use sort of a math analogy too, when we try to judge everyone by one-dimensional metric or definition, we fail at true inclusion and diversity. We lose that opportunity for real creativity and synthesis and innovation because we're judging by that one sameness. So we're losing so many axes of information. It's a projection. It's a one-dimensional projection that's not going to get you all the beauty and information that you would get if you had access to the whole system. And so I think we just need to really, really think about that, really think about all of the axes of diversity and beauty that people bring to us, and then think about how we can foster all of that, especially ones that have been excluded. And so, where is our agency to do that? Maybe it's just a little thing about how we talk about the definition for models and modeling in our classroom. Maybe it's something bigger. Maybe it's, you know, you don't turn away the next person that says they have data for you, even if you're not somebody that works with data. But think about how you can make room and be belonging, offer that belongingness to others. So again, I just want to say thank you so much. I want to thank my co-authors on this paper, Dr. Hannah Callender-Highlander, Cam Dahlquist, Lamar Glenn Letter, and Richard Schugert. And again, I'll try to find the link and give that to Bruce for the paper. It's called Rule of 5, Models and Modeling. Thank you all.
All right. Thank you, Carrie, for the wonderful talk. That was great. So as of right now, there is some time to take a couple of questions. So I'll open the floor. You can either just unmute yourself and ask a question or put it in the chat. So go ahead.
I have in the chat, I put the documentary Picture a Scientist about women's problems in science and being accepted, et cetera. It will be on PBS tomorrow on the NOVA program tomorrow night. So that's a great opportunity for everybody who hasn't seen it to watch that. And the comment I have is that, you know, you're talking about language there very nicely. Disciplines, each discipline has their own language, and you have to surmount that to do interdisciplinary work. Way back when, my husband and friends who published a paper in the physics, he's a physicist, and they published in the fisheries review as opposed to the physical review, because they were tagging trout in the Asable to determine overfishing. And the fisheries people had a different vocabulary than the physics people. And they were asked to change some of the wording in their paper, and they refused to change, and it was published anyway. but yeah, there's always I think nowadays, that was quite a long time ago. Nowadays, people definitely, there's so much more interdisciplinary work. It's much nicer. And thank you for putting Talitha Washington's photo in there in your slide.
Yeah, she's wonderful. Yeah, I think, you know, it was interesting too. It's not just about, I think there's a whole lot of relationship building that goes into interdisciplinary work that folks might not recognize or know. Language is just a part of those cultural relationships that are being built, but equally important. I'm glad you bring that up in terms of research. I remember when I was trying to do some curriculum revising work, because I was working on revising the curriculum for biology majors. And I sent a survey out to all of the environmental science and biology instructors about like which calculus topics do you think are the highest priority, and like only a few responded and many had questions. And I went back and I was like, well, you know this, like this is, you know, when I say derivative, you know that means that you want me to talk about rate of change in class. And they're like, oh, rate of change, yeah, that's totally important. Derivative is not so important, but rate of change is totally important. And I was like, okay, pause on that survey. I rewrote the entire survey, but had the translation language there. I got great response rate and I got lots of really good information and conversations, but I had to stop using my language and I had to use theirs.
Mm-hmm.
Any other questions for Carrie?
So I have a question. Thank you. It was a fantastic talk, and I'm not a mathematician, so but I enjoy thinking about models in terms of a broader conceptual approach. So my question is a little more pragmatic about your virtual center and kind of how you conceptualized or modeled entering into like a national or international conversation as a small institution, because I'm often thinking about how convening often happens at like R1 schools because there's a lot of resources and there's a lot of faculty and there's just, you know, a lot, right? And so, but at the same time, I think that smaller institutions and faculty at smaller institutions could also convene in interesting ways. And I'm still trying to figure out what that looks like. And so I was really, my ears perked up when you were talking about like having a virtual center. And I was just wondering how you went about finding that niche in the ecosystem.
Yeah, so this is a really good question. I don't know what discipline you're from. Is it, you said niche quite well. Is it biology? No.
No, I'm actually a literary scholar.
Oh, okay, great.
But I did my first book on systems theory and poetry. So, so a lot of
awesome interdisciplinary example. Yeah. So like, so let's go back at even the Cubes workshop. NIMBIOS has been a longer supporter. Yes, NIMBIOS is housed at UTK. They are an R1 institution, but they actually have these solicitations for working groups that you can apply for, and they sort of allow the space for such a convening, such that you can invite different people from across a variety of places and then have this meeting together. And so that's really, if you don't have the capabilities yourself, like, you know, find a great partner that is willing. Bates is a little bit different. It's a small college, but it has conference capabilities. So like, because we host Gordon Research conferences, for those of you who are familiar with that mechanism. And so I have been able to like convene people here because we have a great cafeteria with amazing food that people will travel from all over for. I think partnerships is absolutely key. You know, my very first, you know, the institution I was at previously, when I first got there, they didn't have any kind of mechanism or grants office to apply for a grant. Like the college had zero like NSF grants because there was just no mechanism for that. Or maybe one that it was a subaward. So I learned, oh, I can get a subaward. Okay, well, I'll partner with, you know, XYZ at institution and they can write it and I get the subaward. And then that led to more formal grants office, et cetera. And so I'm a big fan of partnerships at CORE and finding partnerships that are gonna make that work move forward. I think you're right, now convening can even happen over a Zoom. And so I think there are small ways to even get there and start that conversation. You know, I think there's, of course, some added benefit when you have a more intensive in-person convening that you can really spend some serious time digging down, but it can happen a lot of different ways now. And I wouldn't worry about being small as a reason not to. I remember a colleague of mine got a really nice grant for looking at undergraduate research in mathematics out of her Association for Colleges for Liberal Arts. So like it was just a regional grant, but it brought together like 10 or 15 institutions of all people who were advising theses in math and got to talk about how to engage undergraduates in that experience. And so lots of opportunities, lots of partnerships that I think can really help be the road to that work.
Thank you, that was great. And if I could follow up, I was just gonna say too, that I think the reason why institutions that are smaller should be participating in these national conversations, especially when you're talking about pedagogy, is that your model is gonna change based on the context in which it's applied, right? So if you think about like a pedagogical practice or an assumption about the way a classroom works, that's going to look very different from institution to institution, context to context. And I think the more diverse those conversations are, the better, because people can talk about a kind of subset of institutions when they're talking, and then generalize claims about pedagogy writ large, which don't translate to all the other institutions that are out there. Mm-hmm. So it's just, that's why I really appreciate the kind of meta cognitive aspect of what you're doing in this work.
Yeah, and I'm glad you also bring that up too, because I think this is why community colleges need to be more engaged in it. Like where is most of the learning in introductory math happening? Like it's actually probably at the community college in the post-secondary context. The small liberal arts institutions that have a lot of ingrained teaching expertise, you know, need to be part of that conversation. There's a huge movement to sort of invest in infrastructure to have those conversations at minority serving institutions as well. And this harkens back, I remember making some early pedagogical innovative choices that were relying on certain quote unquote best practices in calculus that I was just sort of adopting into my classroom into a context that was a small liberal arts college, environmental liberal arts college with nobody who wanted to be a math major, and had a very, I don't know, I think the math meeting SAT was something like 480. So the best practices I was adopting were not working. And then I thought, wait, where have those been validated? It was at University of Michigan in an R1 climate with the median math incoming SAT of about 750. So I realized very quickly that's context matters. Exactly what you said, Paul. Context totally matters, and I think it's so important. It's so important for us to be part of that conversation.
Okay. Any other questions for Carrie? All right. Well, if there are no questions, I would like to thank Carrie again for this wonderful talk she gave. And I hope everyone has a good night. Thanks again, Carrie.
Yeah, thanks, and thanks for having me. Ciao.
Thank you very much. Bye-bye.
Bye.